Okay, I'd like to start just a discussion on quantum numbers here. Um, if you remember, we named four quantum numbers. So just make sure you realize there are four quantum numbers. The four quantum numbers. And now, first off, a quantum number. Um, a quantum number is a number that we use to describe the probable location of an electron in an atom. If you have that handout I gave to you, when we do the math to solve Schrodinger's equation, we end up with four numbers, and those are the four quantum numbers that will describe the location in space that will probably find the atom. All right, so the first quantum number is just n. All right, and n can be any number from 1, 2, 3 through infinity. Whoops, that's alpha. Through infinity. It has to be a whole number, of course. And n correlates nicely to the periodic table because n will always equal the rho on the periodic table. If we're discussing the valence electron of certain atoms, the n will tell us which row to look at to find that atom. All right, so n can be any whole number. All right, the second one that we have is L, and it's often written lowercase, and that is confusing. But L is called the angular momentum, or azimuthal quantum number. And N is going to give you the shape of the orbital. Okay, so here we have shape, and N is pretty much relative to size of the orbital. So now we know the shape and size of the orbital. That helps us to know, probably where we would find it. It's probably in this size and shaped orbital. So those two are nice to know, but we don't know everything yet. The third one is the ML, and it's called the magnetic quantum number. And it can be equal to values between negative L to positive L, including 0. Now let's go up here because I forgot to write this. The way that we find L is equal to n minus 1 to infinity. Oh, I keep doing that. So we just find n, and L can be any number that's at least one less than n. I hope that makes sense. All right, so I don't think I really wrote that right. Yeah. Let's pause this. Well, let's just erase this. Sorry if you're writing this down, but I just wrote it backwards. I said the right thing, I just wrote it backwards. So L is equal to 0 up to n minus 1, so infinity minus 1. All right, it always has to be at least 1 less than the value of n. Just remember that, 1 less than n, minimum. All right, so then ML will relate to the value of L. It can be between the negative and the positive value, including 0. And the ML, what that gives us is its orientation. So, orientation meaning, is it up, is it down, is it left, is it right, is it on the z-axis, meaning in and out of the board. All right, and there's more than that, but it gives us values that tell us which direction it's going to point. Now, the fourth one is called the MS, or it's the spin quantum number, and this is the easiest one. It's always either plus 1/2 or minus 1/2. And it doesn't matter which you put unless the other one's already taken. Okay, now that's a super short review, but let's try and answer some questions now in the book and try to remember all these four rules for what n can equal, what L can equal, ML can equal, and what MS can equal. Let me, I'll go ahead and group all these parts together and shrink this down a tiny bit. That didn't work. make this a little smaller. Oh, I missed a part, but that's all right. Okay. So here we go. Let's look at some problems in the book. It looks like number 49A. So 6.49A says the following. For n equals 4, so they're telling us n equals 4. What are the possible values of L? Okay, so I just come up here. That's the piece that I forgot to take with us. Let's put that right here. So, if we look, n is 4. They're telling me that. L has to be, it's between 0 and n minus 1, so it can be 0, 1, 2, 3, because 3 is at least 1 less than 4. All right, hopefully you got Robert's sneeze in there. That was kind of funny. Okay, so if n equals 4, then these are the values that we can have for L. 0, 1, 2, 3. All right, so that wasn't hard. B, for L equals 2, what are the possible values of ML? So now we're talking ML, and we're only looking at 2. If you look at ML, it is defined as negative L to positive L. So I'm going to take this 2. I can have a negative 2, a negative 1. I include 0. I have a 1. And I have a positive 2. Okay, and that's all for 649A and B. Ugly that I did them up there, but that's okay. So, if n equals 4, then L can equal 0, 1, 2, or 3, and ML can equal, if it's particularly negative 2, or sorry, 2, it's negative 2, negative 1, 0, 1, or 2. Piece of cake. Let's do another one. Well, it's not in your homework, but let's do 6.50 just to review, or to help us. How many possible values of L and ML are there when n equals 3? So A, we're going to talk about n equals 3. And then B, when n equals 5. All right, so this will be kind of some busy work, but we can do it. So possible values for L, remember it's 0 to 1 less than this. So my answer is going to be over here. So I have 0, 1, 2. So the answer, it's kind of tricky, is that there are 3 possible values of L when n equals 3. Now notice those two numbers are the same. That's not a coincidence. All right, so there's for L, but what about ML? Okay, so that's 1/2 of my answer. All right, what about ML? For ML, we need to look at all these parts. So remember, ML is negative, oh, come on, negative L to positive L. And we're going to have to do this for all 3 of these values, because it wants how many total. So negative 0 to positive 0, that's easy. So when n equals 0, I only have 1 possibility for that. Now, when n equals 1, I have negative 1, 0, and positive 1. So that's 3 possibilities. When n equals 2, I have negative 2, negative 1, 0, positive 1, and positive 2. So that's 5. All right, so 1 plus 3 plus 5 is 9 possible values of ML when n equals 3. Hope that made sense. Now, why don't you pause it and give yourself a shot. Now, to pause this, it's kind of dumb format, but just push the button on your mouse. To unpause it, just double-click it back, I think. Pause it and give it your best attempt. Okay, let's go ahead and figure this out now. So if n equals 5, then L is equal to 0, 1, 2, 3, 4. So there are 5 possibles. Now, this is a pain, but you'll see up here we already did 1, 2, and 3, so they're right here. 1, 3, 5. 1, 3, 5. Now you might see a pattern there, and let's make sure the pattern works, and then if it does, will be great. So 3, to find the ML, it would be -3, -2, -1, 0, 1, 2, and 3. 1, 2, 3, 4, 5, 6, 7. So we would have expected 1, 3, 5, 7. I'm not going to work out 4. I'm just going to tell you it's 9 because that's the pattern. It does increase by 2 every time, so that's great. All right, so this is 9 plus 9 is 18 plus 7 is 25. So 25 possibilities for ML when n equals 5. All right, that's 50. Now, it's not on your homework, but it's a good exercise.